So, picture this. It's the holiday season, everyone's trying to travel, and then bam, a huge storm just wallops the northern United States. We're talking full-on blizzard conditions, crazy cold temperatures, and just treacherous roads. It was total chaos. So what was the deal with that storm? Well, in this explainer, we're going to break down exactly what happened.
The first thing you noticed was just the absolute gridlock. I mean, the impact on travel was staggering. Over 9,000, that's 9,000 flights were delayed. And on top of that, nearly 900 were just flat out canceled. Airports were a mess, and holiday plans for so many people were just thrown into complete disarray, all because of this one storm system.
And it wasn't just about getting stuck at the airport. Oh no, this storm hit people right where they live. On just a single Tuesday morning, 27,000 customers woke up to no power. Can you imagine that? In the middle of a blizzard and your house is cold and dark. That's the real on-the-ground impact of a storm this intense.
So what do you even call the thing responsible for all this mayhem? Well, meteorologists have a name for it that sounds like it's straight out of an action movie, a bomb cyclone. But what on earth does that actually mean? And how does a storm get a name that explosive? That is exactly what we are going to unpack.
So the secret behind the bomb cyclone is a process with an equally dramatic name, Bombogenesis. Yeah, it sounds intense, and honestly, for very good reason. This is the key to understanding why these storms are so uniquely powerful.
Okay, so what's the official scientific definition? Well, for a storm to get slapped with the bomb cyclone label, its central atmospheric pressure has to absolutely plummet. We're talking a drop of at least 24 millibars in just 24 hours. That incredibly fast pressure drop, that's the bomb we're talking about.
Let's walk through how this actually works. It starts out simple enough, right? You've got a mass of low-pressure air and it meets a mass of high-pressure air. Now, nature doesn't like a vacuum, so air flows from high to low. That gives you your basic wind. But then, step 3 happens, bombogenesis. That pressure in the low-pressure system just tanks, incredibly fast. This makes the difference in pressure between the two systems huge, and that supercharges the winds. It's kind of like taking the dial on a giant fan and cranking it from low straight to the highest setting in an instant.
And hey, don't just take my word for it. This quote from AccuWeather really puts it perfectly. Because all that air is rushing toward the storm center so fast to fill that low-pressure void, what you get are some of the most violent weather systems you can imagine, and they're capable of doing damage over a huge area.
Okay, so these storms are clearly powerful, but are they rare? And do they just, pop up anywhere? Let's take a look at where and how often these cyclones actually form.
Well, it turns out there's a prime breeding ground for bomb cyclones, and that is the western North Atlantic. So why there? It's basically the perfect recipe. You've got this frigid air coming off of North America, and it collides with warm, moist air hanging over the Atlantic, which is often supercharged by the warm waters of the Gulf Stream. That clash is the perfect trigger for bombogenesis.
Now, given how powerful they are, you might think a bomb cyclone is a once-in-a-decade kind of thing. But a 2021 study turned up a pretty surprising fact. On average, we see about 18 bomb cyclones near North America every single year. That's right, 18. They are not nearly as rare as that dramatic name might make you think.
So we know what they are, we know where they tend to happen. Now let's get back to the most critical question. Why are they so dangerous? Let's look at the specific threats a bomb cyclone brings to the table.
This is basically the storm's whole arsenal. You're talking destructive winds hitting 80 kilometers per hour, which is more than enough to bring down trees and power lines, and that explains those 27,000 power outages we talked about. They can also cause major lakeshore flooding, dump incredible amounts of snow leading to blizzards, and sometimes they can even produce lightning. It is a multi-threat event, for sure.
So after digging into the science, the location, and all the dangers, what's the single most important thing to remember about a bomb cyclone? Let's boil it all down to the main point.
And this is really it. The term bomb isn't just a catchy phrase for the media. It's a scientific description of that rapid, explosive intensification happening right at the heart of the storm. The name is a direct reflection of the physics, a sudden, massive drop in pressure that unleashes a ton of energy.
And all of this leads us with a final and pretty crucial question to think about. We know these storms are born from that clash between cold and warm air, and they're fueled by ocean temperatures. So as our planet's air and oceans keep warming up, how is that going to change the behavior of these powerful storms? Will they become more frequent? More intense? Will they pop up in new places? That's something scientists are working really hard to understand right now.